How many people have heard of Couchbase? All right, that's good too. Well, if you've read the agenda, what I was asked to talk about today is whether NoSQL databases are disrupting the database industry. And so I'll talk through that a little bit. I'll start with the obligatory slide for the few of you who maybe don't know as much about Couchbase. I'll just quickly go through an overview of the company, and then I'll get right into the subject of whether this technology is disrupting the $40 billion database industry. So Couchbase, for those of you who don't know, is one of the leading NoSQL database companies. We're located here locally in Mountain View. We're an open source company like most of the NoSQL database companies are. We have both an open source development model as well as an open source distribution and business model. Like other NoSQL databases, we're really focused on internet and mobile applications. And by internet applications, I mean applications that you access using a browser that's connected to the internet, where the processing of the application really, for the most part, takes part in the cloud, where you have an application tier and a database tier. So that kind of a three-tier software architecture. For those kinds of applications, NoSQL databases are increasingly used. For Couchbase, we have more than 200 customers. We've been on the market for about 18 months now, so we're growing very, very quickly. And the customers come from all different verticals. I've listed just a very small number here of some of our more recognizable customers. Zing is actually our largest customer, and social gaming is a big vertical for us. Salesforce, AOL, Docomo, Cisco, Concur, Orbitz are all customers, and as I said, many, many more. So at the very highest level, what is NoSQL all about? NoSQL all about? It's really about providing an alternative to relational databases that provide a much more flexible data model, that provide much higher performance, particularly at scale, and that provide a horizontally scalable database tier that allows you to store very large amounts of data and be able to support applications that have a very large number of users, which of course generates a lot of database operations. So that in a nutshell is what NoSQL is about, and I'll of course talk more about that as we move forward. Couchbase, we think, is the most mature and most reliable and widely deployed NoSQL solution. Just to give you an idea, there's more than 5,000 paid production nodes that are in use today. Since we're an open source company, there's probably several times that number that are being used where people are using the community edition. Like most open source projects, if you're interested in checking this stuff out, go to our website. Find our download page, you can download it, you'll be up and running in 5 minutes. It's storing data in the database, a very easy solution to use. So if you're writing applications or interested in databases or looking to boost your skills, certainly come to couchbase.com and you can learn a lot more. Okay, well that's for the most part all the advertising I'm going to be doing. Let me talk about the bigger subject, which is this NoSQL technology as a whole and the kind of technology that Couchbase is providing, is it really causing a major disruption in the database industry? Today, depending on how you count it, the existing database industry is about $40 billion, and the three main competitors in that space are Oracle, of course, IBM with DB2, and Microsoft with SQL Server. And those big three power most of the business operations and most of the big applications that are in use today. Obviously, a $40 billion industry, there's a lot of this stuff out there. But the business associated with relational database technology is stagnating, and from our perspective, it's reaching an end of life. And by end of life, I don't mean that I think relational databases are going to go away. They're going to continue to be an integral part they're going to continue to be used in large measure. But while today, that $40 billion, the underpinning of that $40 billion industry is about 95% relational database technology. And that's been the case for the last 40 years or so. Everything has been relational technology. The issue hasn't been so much, am I going to use it or am I not going to use it? It's simply which one. And that's what I think is really going to change. I think if you look out 10 years from now, it's too early to tell whether relational will make up 50% of the industry, 40% or 30%, but I feel very confident that it's going to be dramatically lower than the 95% that is the case today. And so that's really kind of what I mean by disrupting the current database industry. Our belief is that going forward, there are going to be a number of different database technologies. Relational will be one of them. And each one of those different database technologies are going to be particularly good for certain types of use cases. And increasingly, application developers are going to pick the right technology, the right database technology for their specific use case. Give you a little bit more of a flavor. I think relational technology really kind of reached its limits to some extent more than 10 years ago. MySQL solved some of those problems within the relational realm, and from my perspective gave relational technology another 10 years. Memcached, which is a caching layer that sits in front of MySQL in many installations, gave it a little bit more leg room because it provided higher performance in that caching tier and some measure of scalability. But I really believe now that relational databases have reached their ultimate limits, and that for a growing number of applications, NoSQL technology is going to be the right solution, and that's where most of the meaningful growth is going to be over the next 10 years. Okay, so just level set a little bit. I mentioned earlier that that the database industry is being disrupted, but it's not just being disrupted by NoSQL technology. And so let me talk about that a little bit. I mean, there are at least two major areas of the database area that are being disrupted. One is NoSQL, and when I talk about NoSQL, I'm really talking about real-time interactive databases, right? And by real-time interactive databases, at a high level, fundamentally, you have some large amount of data, 4 terabytes of data, maybe storing all of the information associated with the social game. And when you come to play a specific social game, maybe it's Draw Something, for example, which I'll talk about later, that some of you may have played. Your database basically have to serve up some very small piece of that database, right? Your information, your account information, the session state information associated with your particular game. And so you need to serve up that relatively small piece of a very large database, and you need to do it really, really fast, like sub-millisecond fast, right? That's what real-time interactive databases are about, and they're architected to be able to support that kind of a problem. For the analytic databases, you have a different problem. You got 5 terabytes or maybe 5 petabytes of information, and you're basically going to ask a question of that data, and you're going to run and look at all of the pieces of data in that database, and then you're going to get an answer to that question, right? So it's a different problem. Typically, real time is minutes, right? Oftentimes those analyses take hours or even days, okay? So the way that those kinds of solutions are generally architected or different is to solve a different kind of a problem. In the analytics space, there's a major disruption taking place as well. A lot of talk about Hadoop, for example. That is generating huge interest and significant growth. That's not what Couchbase does, but it is an area that also is being disrupted. Again, Couchbase is really in the NoSQL space, this real-time interactive space, and that's the space that I'm going to talk about today. For those of you who know Couchbase, you may know some of the other players in the NoSQL space. MongoDB is another open source project. Cassandra, sometimes Cassandra is placed kind of in the middle where these two things overlap. And then in the Hadoop space, you have companies like Clara, Hortonworks, and many others that have attained a lot of notoriety. So a tremendous amount of energy, a lot of growth. This is a career fair, so for those of you who are looking at getting involved in a very high growth, very exciting area, this is an area that if you have skills in this space, you have an interest and a passion in this space, I think it's going to be growing for a long time. Okay, so what are the underpinnings of this huge growth? And there are really four things that are kind of providing the underpinning for the movement to NoSQL technology. One is big data, and big data, oftentimes when people talk about big data, they're really talking about analytics, right? They're talking about how do I take a huge amount of data, ask a question of it, and get some insightful answers, right? For us, in the NoSQL world, big data means something a little bit different. If you look at how the amount of data is growing and what kinds of data are really growing, it turns out that it is semi-structured and unstructured data that is growing very, very rapidly. All right? And by semi-structured and unstructured data, I mean data that's not easily placed into rows and columns of a table. That's one way to look at it. There are many others, right? You're talking about video files, audio files, blogs, text blogs, all kinds of things like that, even logging information. Oftentimes that kind of information doesn't fit well in a very, very structured database. And so that's what's important to NoSQL about big data. A lot of semi-structured and unstructured data that isn't easily represented in a highly structured database like a relational database. Right? The second thing is big users. It's not that long ago that if you had 5,000 users of an application, that was a lot. Or 10,000, or even a little bit more recently, 100,000 users, right? But now that there are more than 2 billion people that are connected to the internet, now that more and more applications are available and are used through a browser, again, where the processing is done in the cloud, you have access to a much larger number of users, and you're finding more and more applications that have huge numbers of users. Social games are, a particular example of that. Oftentimes with social games, you can have, 50 million, 100 million people or more that have downloaded an application, and you'll have 15 million plus daily active users. So large numbers of users that are using an application simultaneously. And so that's a really important thing. We don't just talk about big data, we also talk about big users. The third thing is cloud computing, and in a nutshell, to us what that means is that we're really rapidly moving away from client-server type approaches and architectures for developing applications. That's what was done in the 80s and the 90s and into the 2000s. Now you're seeing an increasing number of applications that, again, are using this three-tier web architecture of a browser connected over a network to the cloud. Within the cloud, there's an application tier that's horizontally scalable, and then a database tier that's horizontally scalable. More and more applications are using that kind of a structure. More and more applications are being written to be SaaS-type applications, and that lends itself to that kind of an architecture. And so I think you're going to see that happening more and more. And it turns out that NoSQL databases fit extremely well into that kind of an approach. And finally, there's mobile. Mobile just multiplies tremendously the number of users that are accessing applications. Oftentimes, they're accessing applications, 2 minutes at a time, as you have a few minutes, between train stops or as you're sitting at a stoplight or whatever. And so mobile is really having a big effect on this as well. So these are some of the underlying trends that are really driving a move towards new technologies in the database area, and more specifically NoSQL. So let me give a little bit of a history of NoSQL. It really started with the Googles and Amazons, Facebooks, LinkedIn's of the world. They were the first companies that really had this kind of web architecture that operated at just incredible scale. They had tremendous difficulty using relational database technologies, particularly, and certainly things like MySQL. And so they, of course, rock star companies, great internal expertise. They had the expertise to develop some new technology internally. I think at least symbolically, the start of the NoSQL industry was when Google published their big table paper in 2006. That got a lot of attention. Everyone focused on how does Google do what they do, and technology papers like this oftentimes have a lot of influence. Facebook developed Cassandra, Amazon developed Dynamo, LinkedIn, Project Voldemort. So this is how initially there started to be a lot of momentum around what became known as NoSQL technologies. Obviously, most companies don't have the ability to develop their own technologies internally. Even if they did, you don't necessarily want to do that yourself. Various open source projects started up, most of which were heavily influenced by these early papers. And then commercial companies like Couchbase formed around those open source projects, and now we have a rapidly growing industry. So that's kind of how things started. And as I mentioned earlier, they're kind of, I mentioned actually 3 of these things. I'll talk a little bit about the 4th, but there are 3, again, primary things that are driving people to use non-relational databases. One is a more flexible data model. I'll talk about that in a second. The second, again, is that it's easily scalable, right? By easily scalable, I mean as you have more users using your application, as you have to store a lot more data, that your data tier can scale easily without affecting the application tier, without having to go through a huge amount of pain. And that's one of the big highlights of NoSQL. And then high performance. More and more applications, again, are served up through browsers. As you all know, if you start to use an application and it's sluggish, it doesn't respond very well, you're going to go use something else, or you're going to stop using that application, right? So being able to provide very high performance, sub-millisecond performance on a consistent basis is increasingly important, and getting that kind of performance out of your database is difficult with relational technologies, particularly as you scale. And then finally, low cost. For anyone that happens to be involved in the purchasing cycle with an Oracle or a DB2, you'll know that it is many millions of dollars oftentimes. You'll also know that many of the internet companies couldn't possibly afford to pay that kind of money given the amount of data and the amount of scale that they have. That's why people moved to MySQL, one of the reasons they moved to MySQL a number of years ago. And so certainly moving to a simpler, more scalable, low-cost, open-source approach is also something that's very appealing about NoSQL. And as I mentioned earlier, the vast majority of NoSQL companies are all based on open source. Okay, so let me dive into the details a little bit more and talk first about the flexible data model. On the left-hand side here, hopefully you can see that a little bit, but for those of you who aren't familiar with relational databases, the simple way to think about them is that they're a whole bunch of interconnected tables, right? And by a whole bunch, you know, if you're doing a small application, maybe a whole bunch is 10 or 20 interrelated tables. But if you're doing a typical, you know, commercial application, you'll have hundreds of interrelated tables, sometimes thousands of interrelated tables. And all of your data needs to be stored in a particular row and column format, right? A row is typically thought of as a record, and then, you know, so maybe the row is your name, and then there's a whole bunch of things associated with you, right? Your first name, your last name, your street number, your street address, your zip code, your dog's name, your parrot's name, whatever else, right? And all of that is stored in these interrelated tables, and you try to normalize all of this data so that there's no, you know, duplication of any data, right? So the problem with relational databases is that it's a very formal schema. It's a very, very structured way of storing your data. You need to define the schema ahead of time. Every time you want to make a change to the schema, you go to your database architect, you try and figure out among these 10,000 tables where to put the column that's going to be able to store the data. You take your old database and you move it over into the new database. It can take a long time. It's a laborious process. It doesn't meet the needs of application developers. It doesn't meet the needs because it doesn't do a very good job in storing a lot of unstructured and semi-structured data. And it doesn't meet the needs of developers because it takes so long to make changes. Right? We're living in a world where application developers are constantly wanting to store new data, new information. They need a data model that's really flexible, that's really agile, that allows them to move really fast. And so the NoSQL data models, I'm going to talk here about the document model, provides a lot more flexibility. First of all, it's schemaless. You don't have to define any schema ahead of time. You get a little bit of a feeling here. I don't know how many of you can see that. But just think of a document as, you know, the name of the document is Bob, right? If it was for me, and then inside the document, it would be first name, semicolon, first name, semicolon, last name, street number, etc., zip code, etc. And if you all of a sudden decide, I want to store pet names for people, and specifically parrot names, great. You just put an attribute in the document that says parrot name, and if my parrot name is Bill, you put it in Bill. And if another person doesn't have a parrot, you just don't put that attribute in it, right? And so, I think you can get a feeling for, that's a much more flexible, much easier data model for people to handle. It also turns out that kind of the interlayered aspects of a document like this is much easier for applications to deal with, right? Once an application gets this kind of a document, to parse it and start using that data turns out to be much easier, right? So hopefully you get a feeling for some of the reasons that application developers would like this document model a lot better for many applications than for a relational model. Second key thing, and I really talk about two things here, is a combination of performance and scalability. And this, really shows that three-tier architecture. You see the browsers on the top left connected over the internet. You usually have a load balancer that balances the load across a horizontally scalable application tier. The key thing about this horizontally scalable application tier is that it's got great attributes, right? In the sense that if I have 10,000 more users, I buy another standard commodity server and fire it up and add it to the application tier. Another 10,000 users, I fire up another machine, right? And so the cost is linear, right? As your number of users grow, your cost goes up linearly with that number of users. Since you're distributing the load across a greater number of servers, your performance is going to stay the same, right? And so people love that kind of horizontally scalable nature of today's typical application tier. The problem today with relational databases is that when you get to the database tier, and if you have a relational database, it's a centralized technology. It's a centralized share everything technology. So if you have more data or you have more users that are driving more database operations, you have to scale up that database, right? You get a bigger machine with more CPUs and more memory and more disk, and you keep getting bigger and bigger and bigger, and then when you can't get any bigger, then you have to shard it, right? And you shard it at the application layer, which means basically you have one database where you put everyone east of the Mississippi, you have one database you put everyone west of the Mississippi, and your application has to know where you're going to get that data. And when you do that, you start to lose many of the benefits of a relational database as well. So now imagine if you're scaling quickly, I mean, you might say, well, it's not that difficult to split my database in two, right? But now imagine your application is scaling very quickly, and you're having to constantly shard your database, split your database into more databases. And then you have to update your application, and you got to manage all of the data between the databases. It starts to become a real mess, right? And so those are the kinds of problems that you have with a scale-up technology, and it's this kind of a problem that the NoSQL databases solve because, and actually I should mention here on the bottom right-hand side, you can see, as is true for many centralized technologies, it scales pretty well for a while, but then all of a sudden your response time starts to increase, and so you don't get the same performance. All of a sudden your cost starts to increase non-linearly because it's more and more expensive to develop more and more sophisticated centralized technologies that have higher and higher speeds, et cetera. And so those dynamics, of course, people don't like, right? So obviously NoSQL solves that problem. And here you see the same browsers at the top, the same load balancer, the same application tier, but now you have a horizontally scalable database tier. And you can see that that database tier, it's shaded, right? Because all of those, even though there's 10 machines in that cluster, it's one database, right? That simply is distributed across a number of machines, right? Not like the relational case where you basically had to split your database into two, right? So from an application perspective, the application doesn't know and doesn't care whether there are 2 nodes in your cluster or 15 nodes in your cluster. The database is going to handle sending a database request to the right machine and serving it up to the application tier. All right, so that's a basic attribute of the NoSQL databases. Each of them do it in slightly different ways. Okay, so hopefully that gives you a reasonable idea of from a technology perspective, why it's different. Let me talk a little bit about just who's using this kind of technology today and where it's going to be used in the future. And then I'm going to spend a few minutes just taking you through a use case so you can get a feeling for what application developers are typically dealing with and how they use NoSQL. So first of all, market adoption. To date, the vast majority of adoption of NoSQL has been internet companies. And so these are companies like social gaming companies, advertising platforms, social networking applications, online business services. I mentioned Salesforce.com before. Online retail. Orbitz became a big customer, et cetera, right? So those are just examples, but it really runs the full gamut of verticals. Now we're starting to see enterprises move into NoSQL in a big way. Most of the early applications that they're using NoSQL for are the same kinds of internet applications that are used by the internet companies. So here we have customers like Starbucks and Honda and BMW and those kinds of companies. And here, of course, internet applications are an increasingly important part of their business and their strategy. And so they're developing more and more sophisticated applications, and increasingly they're using NoSQL. A lot of times people ask, what about in the enterprise? What about all these, back office, applications that are running on Oracle and other proprietary relational database technologies? And while I think that some of those will replace certainly pieces of, in some cases maybe all of those, the Oracle or DB2 underpinnings, I think what's more likely to happen is that, for example, in enterprise content management, you've got companies like Documentum that the technologies were built in the late 80s and the 90s. They were all built on a client-server type approach. What you're more likely to see, I think, is you're going to see new enterprise content management solutions that are going to come onto the market. They're going to use a SaaS model. They're going to use this three-tier internet architecture. They're going to support mobile really well. They're going to support, laptops and stuff really well. They're going to be completely different architected solutions for the next 20 years. And those are the kinds of ECM solutions, for example, that are adopting NoSQL technology. And while there might be some replacement that takes place with some of the older technologies, I think, again, this whole movement is a part of a much bigger wave that NoSQL really fits into. And so that's really how NoSQL technology will start to replace those installations that I spoke about earlier. Okay, so try and give you a little bit of a feel for how the technology is used in action. Draw Something was a company called OMG Pop, got acquired by Zynga. How many people have played Draw Something or heard of it? Okay, a fair number. So probably more of you have played Pictionary, and people liken it to Pictionary. So basically what you do is, whether you're playing on your iPhone or your iPad, you of course download the application. You can download it for free. And basically you draw with your finger a picture, right? You basically have three words that you can draw. You pick one of those three words and then you draw it. And then you send it to someone who's in your social graph, and you play a game that goes back and forth. All right, that's the basic idea of the game. I don't draw this well, but one of the things that's been really cool about the game is it's really unlocked a lot of creativity in people. People that like to sketch, people that are real artists. So of course, I picked some that are particularly good and didn't pick my lousy sketches. But anyway, people do pretty elaborate things. So, like a lot of social games, social gaming is really the hits business, right? There's a ton of social games. Many of them kind of, have relatively low numbers of users, and then for various reasons, all of a sudden, one will go viral, and they'll scale at an incredible pace. And Draw Something was the fastest growing mobile application ever when it started growing in March of this year. And you can see here a little bit, on the left-hand side of the screen, it got released in early February, and for about a month it just kind of meandered along without any really significant usage. I'm not sure that OMG Pop knows. I'm sure they have theories about why it went viral, but it went viral, right? And for example, part of the reason it continued to go viral was that Jersey Shore cast members tweeted about it, right? And they weren't the only ones. I think Lohan also tweeted about it, and so things like that are things, of course, that really get the word out there on some of these games. In any case, the key thing is it went essentially from 0 to 50 million downloads in 5 weeks. It went from essentially 0 to 15 million daily active users at its peak. It went from some tens of pictures being stored per second to 5,000 pictures being stored in the database per second at the peak. You went from roughly 0, or very low amount of data being stored, to over 5 terabytes of data being stored. Anyway, I think you get the feeling here. This is a game that's scaling very quickly. The number of users growing very quickly, the number of database operations growing very quickly, the amount of data you're storing very quickly. And what you want to do, of course, is you want to be able to 24/7 by 365, every second of the day, you want the game to be up and running. You want to maintain that very high performance every second, and you want to be able to scale at this enormous pace, right? So this is kind of an outlier, but this is a great example of kind of putting a NoSQL database through its paces and really showing off its advantages. I'm not going to go through all of this data. You can see here, the drawings per second, the total number of drawings, which I didn't talk about. And I think this was through the end of March. It was like 2.2 billion drawings that had been drawn. You can see here that the latency. This latency is actually the latency from the time that a request hits the database itself. The latency from the time the application requests something is sub-millisecond. You can see they went from 6 servers initially, which actually was over-provisioned by a meaningful amount, to well over 100 servers. And all of this happened, again, in terms of these numbers, within a 3-week period, and the game didn't go down, it continued to maintain performance, etc. So this is a little bit of an extreme case, but still it shows the kind of thing that databases need to be able to handle today, and the kinds of things that NoSQL databases like Couchbase can support. It's also interesting to note what happens when you don't scale very well, right? So interestingly, at the same time or roughly at the same time that Draw Something was growing, there was another game that was also starting to go viral. It was from EA called Simpsons Taped. It got to number 2 in I guess on the iPad. It got to number 3 on the iPhone. So it was growing very, very quickly. And then the game started having huge problems, right? There was a lot of lag. The game would go down and it would just crash and then be unavailable for hours. Long story short, at first EA didn't let any other people download the game, and then eventually they pulled the game from the market, right? So now imagine if you're an application developer, you've just developed this game that went viral, you're super pumped up, all your friends are playing it, you're showing everybody, and all of a sudden, poof, right? It goes away, right? And again, this is kind of an extreme case, but even if you're running a business and all of a sudden the game or not the game, your application is down for a few hours or a few days, it's costing you a lot of money probably, right? So increasingly, you've got to be confident that you have the performance, you have the scalability that you need, and again, that's why people are increasingly running to NoSQL. I lied a little bit. I guess this is an advertisement too. If I've gotten you a little bit pumped up about NoSQL, if I've gotten you a little bit pumped up about Couchbase, it's all open source. There's community edition. If you want to actually do development, download the source code and you can help with development. If you just want to use it, play around with it, use it for free to your heart's content, use the community edition. If you're a user that's using it in production and you want help, of course we have Enterprise Edition to do that as well. And that's a career fair. We're hiring. You can visit us here at the career fair. We have a booth inside the other room. Or if you can certainly come to our website and or give us a call. We're local. Thanks.